We're here today to talk about creating and operating ML models from event-based data using a feature engine and a feature store. So I wanted to start with a story. It's a true story. And just the other day, I was talking to, he was a general manager of a gaming company, a very experienced executive leading data science, design, product. And you know what he told me about machine learning? That they have made many investments over the years to attempt to predict engagement and retention, to be able to influence the outcome, but they keep failing at the more advanced steps. And he went on to say that they have trouble identifying exactly what's causing new users to churn and leave, and to get that real promised value out of machine learning. And I'm sure if you're here today that you may see yourself somewhere in this story. Maybe building your first machine learning model was okay, or the second or the third, but for some reason, getting the impact is quite difficult. And part of that impact that we're looking for is what I want to talk about in the coming stories today. These are large. You can get up to 35% impact on your revenue in personalization, or 13% in recommendations, et cetera. But unfortunately, building these features are typically complex, very manual and frustrating. It's why big tech companies are making these impacts. And feature stores solve some of these problems, like operationalizing and standardizing feature definitions. But data scientists spend most of their time trying to discover features in the first place. What is predictive? What should I care about? And feature stores are limited by the capabilities of the data processing engines that populate them. So traditionally, you can't get to this very easily. And in the coming slides, I want to really share our point of view based upon the years of experience we have building an iterative time-based feature engine and partnering with feature stores. Creating and operating ML models directly from event-based data isn't a wild idea. It is, in fact, what many of you are collecting with customer data platforms like Segment and Heap. And if you're collecting this event-based data, you don't have to be right up front. You don't need to know exactly what's going to be predictive. And so this motivates why you'd want to create models directly from event-based data. But if you don't have to choose and you don't have to be right, what's so important about it? And this data, this structured data where we store facts like at this point in time, this specific person or entity made a specific action. This is things like activity data streams or transaction data streams or logs. The key here is that great models take advantage of features that take into account this notion of change over time. And because time is the most important factor, you can build models that correctly predict things like engagement and retention, churn or interest or action, anything else really. But the reasoning about time is key, the key that can enable you to succeed where it's been difficult before, if you remember the story from a moment ago. Because, we need to start with high quality data, high quality features. So let's look at a diagram of the machine learning process. Pretty simple. Obviously, we start with raw data. You have to do some form of feature engineering and then train a model. And then obviously you would want to then you share those features, make them discoverable and between people and models, and then get to production, actually make an impact, operationalizing both the models and the features. And for features, we typically want to cache them and store them to make them easily available, low latency. It's all obvious. But on the feature side, this lower line on the diagram is some combination of these three middle steps, is what's been referred to as a feature store in the industry. And these three steps are what we're going to be talking about today, looking in depth at each of these necessary steps. But rather than jumping into a solution, I think we should talk a little bit about the problem, because the problem is what you're here to solve. When things don't work out, when things get complex, and this is nearly universal with event-based data, that we need to power these most valuable models, this is where we need to look. So what really happens in these cases is that you discover that building features from event-based data is more complex than you think. This is when machine learning companies train their customers. These are the steps that comprise the feature store. But before any of this works, there's so much pain. Pain of building ETL pipelines, pain that the needed data is missing from those pipelines, pain of managing backfill jobs, those that particularly you need. And then when we somehow make it happen, we discover that there's temporal leakage and that we have to start over and go back through this process. And honestly, really, this is what no machine learning company wants to say. But we all know that it actually happens. It's happened in many companies that I've worked at before. What happens is that models take quarters to get into production, that the vast majority of the time goes into feature engineering and all of these repeated steps. That's where the problems are. And this is the key. The problems are in feature engineering and feature generation. And this is supported by numerous studies out there. I'm sure you've read some of those as well. So, not surprisingly, I lead one of the companies that provides machine learning software. What Kaskada has solved in machine learning for structured event-based data enables you to build models that leverage time. And so if you have use cases in personalization, risk modeling, forecasting in your industry, it's never been easier to build models that move business KPIs. But there are other situations. There are more kinds of models out there. And in those situations, there are great companies that can help, and definitely talk to them. Just be wary of building yet another low-level, bespoke, not domain-specific platform. Okay, so let's talk about what you need in a feature engine to create and operate ML models from event-based data. As you can imagine, I've spent my career thinking about and talking about what is needed for data scientists to be able to iterate quickly and create impact, solving hard problems instead of focusing on data cleaning and prep. So this engine here, your engine, needs to be able to load data directly from raw event-based data, like Parquet files stored in S3. The engine should be built so that data scientists can iterate in their favorite environments like Jupyter. They need to be able to load their own data, as well as access existing resources like tables and views and groups of features that power models already in production. And this engine should allow data scientists to iterate quickly, supporting external libraries that are familiar to them at different key stages of the feature and model development lifecycle. Things like visualization or experiment tracking, model training, and validation. And the data science experience, this really needs to be instant and iterative in a time-based way. And these time-based transformations are key. So let's explore that data science experience. Remember our story. We're building this engagement model for playing games, reducing the data to find the right example to learn from very specific points in time is key. When you look at these key behavioral triggers, you'll see that they're not all happening on time boundaries. Like you can't make it hourly windows or daily or monthly or weekly. These things like the first session start, or the first time a player missed a day, or every time someone misses a day, getting stuck, these are event triggers. The actual event times relative to each other is what is important. So the first key requirement here is that when you compute directly from event-based data, not from pre-aggregated pipelines, you no longer need to know ahead of time what data points to collect at what points in time in order to learn. Instead, you need a way to express temporal computation, to compute from the events themselves about the level ended, the ad seen, the purchase event, and their relationship to the lifetime survival of the player in order to build your training data set. So first, feature definitions define what to compute. Feature 1 here could be the average stars earned at the level ended event. For every item, there will be a history of events. The language that you use for this engine needs a way to express these relationships between events. And there are hundreds of players, thousands of players, not just one. The day one retention for mobile games is about 25%. 94% of players leave in the first month, and this is typical for mobile gaming. they generate hundreds of thousands of events per day. And so we also need a way to express what events to include and what to compute these examples for your model to learn from. So in the past, feature engineering from pre-aggregated pipelines, they limit the features. They're limited by the snapshots. And here you no longer need to know ahead of time what data points to collect and at what points in time to train a model. So the second key requirement then is for instant iteration for your feature engine, you need the ability to have data scientists select when to compute features. This is part of the model's context. When will the model operate in the real world? Critically, when to compute isn't just clock time, isn't date times. When is data dependent and includes things like after a tutorial is complete and when the next level attempt is played. This way, computations can be observed at meaningful times to produce training data sets. And ideally, a quick code change is all you need to produce the full history of a new computation to enable rapid testing of hypotheses. In this example, prediction times for average stars earned will need to occur when the player finished each level attempt, for example, or when the ad is served to see whether or not that impacts their challenge. Or maybe when they pay for the first time, are they more likely to stay longer? Playing can begin over their lunch break or in the middle of the night. They may pause, they may stop, they may start. This is just like things in Netflix and watching movies and getting recommendations. And in the past, waiting for new feature data to be collected or complex backfill jobs to compute meant waiting 2.5 months for A/B tests or things like that to resolve a single hypothesis. And so you don't want to replace the same problems that you had before. You need to solve those with your feature engine. Okay, so these two requirements may seem like that's enough, but there is another critical need when you enable computing directly from event-based data. The key features to predict survival may include events on other entities, information about the difficulty of a level, stuff about the region, the device, or related games can be important. And when you're computing directly from event-based data, joining values between different entities at precise times without leakage is critical. You can't just do a SQL join. These types of joins happen at the end of time, not for every single event that occurs. Operating on the resulting data from a feature store or a data preprocessing pipeline is the leading cause of leakage and underperforming models in production. This after seeing amazing performance in the lab, right? And for real-time applications, this gets even worse because computing at row-level feature store times isn't enough. And in the past, you would have had to find a way to line up all of the row-level event times from discrete data and then sort of join those together by hand and then hand construct this data set. But with a native time travel feature engine, you can compute features at different points in time to see if your model would be more accurate and predictive without having to do all of that work up front. And now this may seem like enough, but there's one last piece to complete the iteration cycle. You have to actually put our new model in production to test how predictive it is today. Because learning from the past, you could overfit or underfit, or any number of things could have happened, sampling bias, etc. And so we come back to this slide. So once a data scientist is working in a team or needs to get a model into production, the resources need to be shareable, discoverable, persisted, and maintained. A feature engine isn't worth anything if you can't actually put the model into production. And so these resources are things like table definitions, feature definitions, views, and the materialized feature values themselves. These things are all needed for day two experience and for getting to production. And so this feature engine that you need to create these models need to operate them in production as well. So it needs to easily integrate with your existing production workflows, supporting things like environmental configurations or manage through source control of like YAML files or something of that sort. Because you need the flexibility to support central and decentralized teams. So the entire flow is governed alongside the applications that deploy your process, like the CI/CD. And it needs to easily integrate with your chosen feature store or feature caches based upon the model needs in production. You may have different models who have different requirements. And this engine allows you to select the feature store that you need for your requirements. For things like high throughput and low latency, you may choose something like Redis. For discoverability and orchestration, you may choose one of the many others. Okay, so you likely already have some of these architectures implemented today, or some close variant of them, whether it's a first generation two-tier architecture or the newer Lakehouse platforms. If you're adding a feature engine to supercharge any of these architectures, as long as you connect it directly to your event-based data, then you can create models from event-based data that respect all of those requirements that we talked about. If you're connecting your feature engine to pre-aggregated pipelines, you're risking loss of signal. You are going to potentially get leakage in the end. So when you're thinking about adding this functionality to get better performing models so that you can compute features directly, you need to connect it directly. That's what rapidly changes the iteration cycle to go from idea to production in days and weeks and not months and years. And so I hope this was helpful. I hope that you have a better idea of some of the things that you're going to need to create and operate these models. And I'm around. So like I said, I'm Charna Parkey, the VP of Product at Kaskada. I've spent most of my time thinking about these types of problems, talking to customers about these types of problems, from gaming all the way to supply and demand and otherwise. So happy to take questions if you have any.